Rudolph the Red-Nosed Reindeer is Father Christmas's favourite and most important reindeer. Without Rudolph, Father Christmas's sleigh would be unguided and he could crash on his way to deliver all the presents. Every year, children all around the world leave carrots out for Rudolph to keep him going throughout the night. Which made me think, how many carrots does Rudolph actually need in order to guide the sleigh? We're going to find that out today. In order to work this out, we need to make some assumptions about Rudolph. The first of these is that Rudolph's nose acts in a similar way to a car headlight, because car headlights need to be able to guide the way for the car. So in the same way, Rudolph's nose needs to guide the sleigh, so we're going to use a similar power for Rudolph's nose. That is about 55 watts. That's what a car headlight works at anyways. So we're going to assume that Rudolph's nose uses a power of 55 watts or 55 joules every second. The second assumption we're going to make is that Rudolph makes this light using some form of bioluminescence, similar to the loose jaw fish that is found deep underwater. The third assumption we're going to make is about Rudolph's mass. Now, we're going to assume that Rudolph is quite a heavy reindeer, given that he's got to be quite muscly in order to guide the sleigh. So we're going to say he's on the heavier end of the average, and an average reindeer weighs between 180 to 250 kilograms. So we're going to assume that Rudolph's mass is around 250 kilograms. And finally, for this video only, we're going to assume that Rudolph only eats carrots. All he can eat is carrots on his, throughout the year and on his trip around the world, because children leave carrots for Rudolph. So we're going to assume he only eats carrots. So the first thing we need to understand is energy. So how do we measure energy? Well, energy is usually measured using the standard unit, joules. So 1 joule is equal to the amount of energy transferred to an object when 1 newton of force is applied to that object and pushes the object 1 meter in the direction of the acting force. And remember, if you have forgotten all about Newton's laws and what a force is, head over to the Newton's laws video that I did a few weeks ago. You can find that in a card above. So when talking about food, we tend to use the unit of a calorie rather than a joule. So 1 calorie is equal to the amount of heat energy required in order to raise the temperature of 1 gram of water by 1 degree Celsius. When talking about food, we tend to use the term calorie when we really mean the kilocalorie, which is 1,000 calories, or the amount of heat energy required in order to raise the temperature of 1 kilogram of water by 1 degree Celsius. And that's why some people refer to it as the food calorie, because it's the calorie that we're talking about when we talk about food. So the energy that we use to measure food is in kilocalories. Because of this, throughout the video, whenever I refer to energy, I'm going to be talking about it in terms of kilocalories. And if I say the term calorie, I actually mean a kilocalorie. And finally, 1 kilocalorie is equivalent to 4,184 joules. As I mentioned a bit earlier, we're going to assume that Rudolph creates this light using some form of bioluminescence, similar to that of the Malacostus fish, otherwise known as the loose jaw fish. These fish produce red light using a combination of filters and fluorescent material. They do this by creating short wavelength light within the photophore. This light is then absorbed by a fluorescent pigment, which re-emits it as red light with a wavelength of around 625 nanometers. This is then filtered to a wavelength of around 705 nanometers. Now we're going to assume that Rudolph uses a similar process within his nose in order to do this. Maybe not exactly the same way, but a similar process in order to get the red light from his nose. So how much energy is required for the light? Well, as I mentioned before, we're assuming that he uses a 55 watt nose, we'll call it, similar to that of a car headlight. So 55 watts is 55 joules every second. So that's the amount of energy, so 55 joules every second. And we're going to look at a 24-hour period. So to work out the amount of energy over a 24-hour period, we take our 55 joules per second and we multiply that by the amount of seconds in a day. Don't worry, I've done this for you. 86,400 seconds are within a day, so we multiply 55 by 86,400 to get our final value of energy in joules. And again, I said we're going to be working in kilocalories, so we then divide that by 4,184 to get our value in kilocalories. So that means over 24 hours, Rudolph requires around 1,134 calories in order to power his nose. So let's look at the total energy expenditure of Rudolph. So this is the total amount of calories that Rudolph will be using throughout the day. And this is made up using the sum of lots of different things. So we have the BMR, the basal metabolic rate, which is the amount of energy used at rest. We have the physical activity, which is the amount of energy used, when you're active, and the thermic effect of food, which is the amount of energy required in order to absorb and digest food. And finally, we're going to add on the amount of energy used by Rudolph's nose. So his total energy expenditure will be his BMR, his TEF, his PA, and his energy due to his nose. In order to calculate the total energy expenditure of Rudolph, we need to first understand the total energy expenditure of an average reindeer. So the total energy expenditure of an average reindeer is about 3.057 watts per kilogram. And the mass that we're going to be using for Rudolph is about 250 kilograms. This then means that the total energy expenditure for an average reindeer in watts is 764.25 watts. And also remember that a watt is an amount of energy per second. So this means that it's 764.25 joules per second. In one day, there are 24 hours, which is equal to 86,400 seconds. So to get our total energy expenditure for an average reindeer throughout an entire day, we take our 764.25 joules per second and multiply that by the 86,400 seconds, which gives us a value of 6.6 times 10 to the 7 joules. Now, as I said at the start, we're going to be working in calories or kilocalories for this video. And so this gives us a value of 1.58 times 10 to the 4 calories. Using this value, we can estimate the total energy expenditure of Rudolph. As mentioned previously, the total energy expenditure is equal to the sum of a few little things. These include the BMR, the physical activity or PA, and the thermic effect of food. We're also going to add on the energy that Rudolph's nose requires, because this is an extra energy expenditure that Rudolph will have that other reindeers won't have. We know that the BMR is equal to 60% of the total energy expenditure of an average reindeer. So we will take 60% of the total energy expenditure for the average reindeer. We can also do the same thing with the thermic effect of food, as this is equal to 10% of the total energy expenditure. Finally, we know the energy for the nose, as we calculated this at the start of the video. The only thing that we need to question is the physical activity. Now, if we look specifically at Christmas Eve, Rudolph does a lot of travelling on Christmas Eve, does a lot of running. For the average running deer, the physical activity can be calculated to be 4.75 times the BMR, as a very active running deer could be similar to a very active reindeer such as Rudolph. Now, the average speed for a running deer is around 50 miles per hour. And the average speed for Rudolph on Christmas Eve, according to a Forbes article, is around 4,921,200 miles per hour. So we can work out a scale factor by dividing the average speed on Christmas Eve by the average speed for a running deer. This tells us that we need to scale our physical activity by 98,424. So the physical activity for Rudolph on Christmas Eve will be equal to the physical activity of an average reindeer multiplied by 98,424, which gives us a value of 4.4269 times 10 to the 9 calories, which is around 4.4 billion calories. So the energy that Rudolph would use by doing physical activity on Christmas Eve is about 4.4 billion calories, which is quite a lot. So the total energy expenditure for Rudolph then is equal to the BMR plus the new physical activity which we just calculated, plus the thermic effect of food and the energy from the nose, which comes to around 4.4 billion calories as well. Because the other numbers are so small, they're not going to make much of a difference to the physical activity. Having done that analysis, we get a value of around 4.4 billion calories for the total energy expenditure of Rudolph on Christmas Eve, which is a lot of calories that he needs to consume on Christmas Eve. Now, the question that we're asking throughout this video is, how many carrots does he need? Now we're assuming that a carrot has 25 calories and all of the calories within a carrot are useful for the body. Now this might not be the case, this is just an assumption to make the maths easier for this video. Assuming that Rudolph maintains his body weight, he would need to intake the exact same amount of calories that he is expending. So he would need to eat 4.4 billion calories on Christmas Eve in that 24-hour period. So in order to find out how many carrots, we can divide the number 4.4 billion, or the number for the total energy expenditure, by 25. When we do this, we get a value for the number of carrots on Christmas Eve to be around 177,077,985 carrots. Now, Father Christmas must have a lot of money to spend that much on Rudolph's carrots, let alone the other reindeer's carrots, because they'd probably need a similar amount of carrots. So make sure you put out your carrots on Christmas Eve next year, because obviously we've missed Christmas Eve this year. So next Christmas, make sure you put out as many carrots as you can for Rudolph, because he needs them all. But Rudolph doesn't travel that distance every day. He only does it on Christmas Eve. So given that the largest amount of calories that he expends is during Christmas Eve when he's flying around the world, how many carrots would he need every other day on a normal day? On a normal day, however, Rudolph isn't running for a full 24 hours. And so we need to make some assumptions about how much exercise Rudolph does on a normal day. Let's assume that he sleeps for 12 hours, and for the remaining 12 hours that he's awake, he does 6 hours of walking and 6 hours of running. For an average deer, we can work out the physical activity due to walking to be 2.06 multiplied by the BMR. Now if we're just looking for a 6-hour period, we would divide our BMR by 4, and times that by 2.06 to get the amount of energy that Rudolph would use by walking in 6 hours. To get the energy expended while running, we would do the same thing but multiplied by 4.75. When plugging the numbers in, we get the energy expended due to physical activity to be about 1.61 times 10 to the 4 calories, or about 16,000 calories. So the total energy expenditure for Rudolph on a normal day then is equal to the BMR plus the physical activity which we've just calculated, plus the thermic effect of food, and finally plus the energy due to his nose. This comes out to being about 2.8283 times 10 to the 4 calories, or around 28,283 calories. So on a normal day, Rudolph burns around 28,283 calories, but on Christmas Eve, Rudolph burns about 4.4 billion calories. So a slight difference between the two. So having done the maths for that, we get a total energy expenditure for Rudolph on a normal day being around 28,304 calories, which in comparison to the 4.4 billion isn't that much. So how many carrots would he need? Well, again, assuming that he doesn't lose any weight and he maintains his body weight, he would need to eat 28,304 calories throughout the day, every day. So we can take that number, the 28,304, and divide that by the calories in a carrot, which is 25 as we've said, which gives us around 2,286 carrots that he would need to eat every day, give or take a carrot here and there. So that's not as bad, however, still pretty difficult to eat over a 24-hour period, I think. If you've enjoyed this video, please leave a like, and don't forget to comment with any videos you want me to do in the future, or anything that you've enjoyed about the video, anything you think I could have done better. Leave that in the comment section below. And if you really enjoyed the video, please consider subscribing. As always though, I'll see you in the next one.